I want to have a look at LED tubes and see what's involved in retrofitting them into the older fluorescent fittings. Are the two technologies really compatible, and what do we have to do to make it work? To get the right LED tube, we need to know what type of fitting we've got. Basically, you get fittings with a magnetic ballast or fittings with an electronic ballast. The magnetic ballast will have a starter, which you can often see on the outside of the fitting. Sometimes it's internal though. Fittings with magnetic ballasts are generally the older type. It's older technology. Sometimes takes a couple of goes to strike up. It'll flash a few times and it'll start. You sometimes get a very slight hum, or sometimes not so slight. And if you hold the camera up to it, the magnetic ballast, and you get kind of stripes and strobing on your screen, your camera phone, that's going to suggest it's a magnetic ballast, causing interference on your phone. Electronic ballasts are generally simpler, in that the control gear are all enclosed in the one device. You don't have the starters and the capacitors. You'll have power to one end of the ballast, then you'll have 4 leads coming out, 2 to each lamp holder. And you can sometimes tell the difference when you switch them on. The electronic ballast is supposed to have a smoother, more reliable start. It'll strike on its first attempt. I think it's worth having a look at how the traditional fluorescent tube actually works. It's old technology, but I still think it's fascinating. Power comes in through a switch into the ballast or choke. The choke has 2 functions. It acts as a current limiter, but it also creates a large spike to strike an arc across the tube. We go from the ballast to the first pin on the cathode. Power will go through that cathode, out on the second pin. That'll go onto the starter. We go to the third pin on the tube, again through the cathode, and the neutral completes the circuit. Now the principle is, once power reaches the starter motor, it starts to glow. It's often called a glow starter. It's a little glass tube with 2 electrodes and a bimetallic strip. When that gets energized, the neon starts to glow and heats up, and the bimetallic strip will bend and create a contact, which will send the power onto the tube. The cathodes will start heating up in the tube. They'll start emitting electrons, and they get all excited and start bouncing around inside the tube. But there's not enough energy there to actually strike an arc across the tube. But back at the starter, because the 2 electrodes are connected, power is going through the electrodes and not heating the neon by an arc. So the bimetallic strips separate, cutting power, which causes a magnetic field in the ballast to collapse, which creates a large voltage spike, which travels through the tube, creates the arc, and we get light. The light is created by all these bouncing particles hitting a phosphorus coating on the inside of the tube, and then we get the visual light. And now, because we've got the connectivity through the gas in the tube, that could run away with itself. The current could just increase and increase and increase. That's when the ballast comes in with its second function, and it limits that current. It's like a brake, slowing it down so it doesn't run away with itself. That's roughly the principle of your fluorescent tube starting. So electronic control gear work by converting the AC supply into a high frequency supply. It's not the best picture, but you can just about see the voltage and frequency. You get an initial high voltage, 500 volts or so, to strike the light, and once running, it runs around about 120 volts. The frequency can be 20,000 hertz or more. You can see 400 on my meter here. I think that's because it only goes up to 400 hertz. So we've mentioned the magnetic and the electronic. There's 2 other types of light you might come across. The fitting that will hold a self-ballasted lamp. That's a tube with the driver installed within the tube itself. Or you get a fitting that's got an external driver, and that will power a non-replaceable light source like an LED strip or such. And you can get some really good fittings, which are also very controllable. You can dim them. And that's where I would go to when replacing lights. But we're talking about replacement tubes. So we're just going to concentrate on the magnetic, electronic and live end. So with the LED tubes, you get direct replacement tubes for magnetic control gear, direct replacement for high frequency control gear, universal tubes which can do high frequency and magnetic. And you can get mains connected, the live end tubes. The universal says it can also do the live end as well. The vast majority of the tubes you see for sale are for the magnetic control gear or the live end. The live end and the magnetic control, pretty much the same thing really. You insert the tube into the owl fluorescent fitting, take out the glow starter and put in the LED starter. That seems to be quite straightforward. The high frequency ballasts, it's a little bit more tricky it seems getting lamps for them. You have to double check that the tube is suitable for high frequency ballasts. Generally, what they tell you to do is bypass the ballast for high frequency and then insert a live end type tube. So generally the tubes have the LED driver at one end and at the other end they have a fuse or a link. And the two ends aren't generally electrically connected together. That could potentially cause a shock risk. And having the fuse or the link at one end does enable the lamp to work. I've got some drawings which better explain this. And it's possible that there's tubes that have power taken to both ends. You can see in this drawing here, live and neutral come in at one end, but it's also taken down to the other end as well. I believe this type of fitting is not permitted, but you can buy all kinds of dodgy electrics online, can't you? And it's possible you might find something like this, an LED tube that's got the live and neutral at one end, but there's no link at the other end. It's just support pins for the tube, which is good in one way, because you won't get a short if you put the tube in the wrong way around, but it would also mean that it won't work if you try to install it in a fitting with an LED starter, because you won't have that return path to complete the circuit. So when it comes to replacing a fluorescent fitting, I guess there's three things we can do. You can buy a whole new fitting, just get rid of the old, brand new fitting, no bother. Or you can keep the fitting and replace the tube with the suitable LED tube, and you might have to swap out the starter for an LED starter. Or you can modify the fitting, they call it a ballast bypass. Basically you're cutting the control gear out, rewiring the fitting so it'll accept the new LED tube. With that last method, the ballast bypass, that's the one you've got to be really careful with. The only real way to know that you're going to have good success with the replacement fitting is buy a whole new fitting. You're not trying to put new technology into old technology. Also, the owl fitting might have done its time. It's given you a good service. Every situation is different. If you just got one or two lights to swap out, I just buy whole new fittings. But you might have many fittings to swap out and they're all in really good condition. It's just the fact that fluorescent tubes will become obsolete. You don't want to waste money buying new fittings. You just want something that works. So as mentioned earlier, companies are now producing different tubes for different ballasts, but you have to be careful with the retrofitting because they're not guaranteeing these fittings are going to work, especially in electronic ballasts. Osram have some good information on their products. They've got this document here, ballast compatibility. Just a quick scroll through. This is for the universal tube, but you'll notice quite a lot of red. Some ballasts will just not work with these fittings. So I guess before you buy loads of them, you want to try one out. Bit of a faff having to scroll through all this to see if the tube will work. And you need to know your ballast. It's surprisingly quite difficult to get straight answers on this when you phone up companies. Getting through to a technical department can be tricky. They don't seem to like to speak to the public. And when you do get through, they're very non-committal. You contact the big nationwide trade stores. They have in-house manufacturing and you can't speak to them. Even the support staff can't speak to technical and they don't give you data sheets online to check this out. So you've got to be careful where you shop and which manufacturer you choose. You've got to be able to speak to them and you've got to be able to get the data sheets with this important information on it. Is it compatible? There is some professional guidance on retrofitting of LED lamps, and there is a standard, which I believe they're working on at the moment, to update it. And we have this advice because it is potentially dangerous retrofitting LED lamps incorrectly. The preferred method is what they call plug and play, or lamp for lamp replacement, where you don't do any modification to the light fitting itself. You only replace the tube and possibly the starter if one is needed. But even that can have its issues. I've got some video further down the line of what happens when you don't follow the instructions. So we look first at just like-for-like replacement of tubes. Let's simplify this drawing of a magnetic ballast. So here we have the circuit with the fluorescent still in place. Let's have a look at the flow of power. Power goes through the ballast, through the filaments, through the starter, back through the filament, and then you got your neutral return. With the direct lamp for lamp, we replace with an LED tube and we replace the starter. Again, the power goes through the ballast. The ballast has no function. It's just sitting there, gently humming, using a few watts of power through the LED driver and back through the LED starter. As you see, it's just a link. Then through to the other end of the lamp, where it goes through another link. Then you return path back on your neutral. So you can see from here, this is just a return path back for the neutral. And we can swap the lamp over. It'll still work. You can follow the flow of power again. The live will go through the link and through the link in the starter. Goes through the LED driver. And you got your neutral return path. So you can have your lamp in both ways round. But this is not always the case. You might make the decision that you want to bypass the ballast, and you can do this in two ways. You can bypass the ballast but still keep the starter in place, and you're still using the existing conductors, and you're taking power to both ends of the fitting as before. Or you can bypass the ballast and remove the starter as well. So you're basically taking a live and neutral to one end. You've got a live and neutral at the lamp holder. So simplified again, we haven't got power at both ends. We've stripped everything out and we've got live and neutral at one end of the fitting. Now we put the same tube in. It'll work fine in one direction. We flip the tube over and as you can see, we've got that link at the other end of the tube, which is creating a short between live and neutral. And when that happens, you're never sure what's going to happen. You know that the protected device is going to operate. You've got a short circuit. How the LED tube reacts, you don't know. That link might be a little fuse and that'll pop, or could be a metal link and you get a hell of a crack. One thing's for certain, your light won't be working anymore. And you'll be up a ladder as well, and you might react and fall off the ladder, or potentially get a shock because there's issues of pins becoming live as well. You should always switch the power off when you're changing tube lights. And not just LED tubes. Fluorescent tubes can conduct, and you can get a shock off one end. Read the point about the tube failing. It obviously depends what's inside the tube. There might be some kind of resistor or fuse that prevents the tube from being damaged if it's inserted the wrong way around. And it's also possible that there's some kind of connection to enable the light to work no matter which direction it's been inserted. This could be slightly problematic though, because you can see it could be possible to energise both ends of the tube and there's a potential shock risk there. Tube manufacturers will hopefully give you some information on the data sheets and packaging, but as mentioned a few times in this video, getting information can be difficult. Some manufacturers have got tons of information, some not so good. So with the high frequency ballasts, you can get high frequency tubes, just a straight replacement. We don't have any starters to worry about. Take the fluorescent out, put the new tube in. I'm not exactly sure what's in the high frequency LED tubes. I went in about 6 different wholesalers. Nobody had one. Most tube manufacturers recommend a ballast bypass for your high frequency fittings, and they suggest 2 ways of doing that. Direct mains to 2 sides or direct mains to 1 side. The direct main to 1 side will be like previously. It'll work the same way. With a power to 1 end tube, you're just basically using the old fitting as a carrier for the tube. They also suggest direct mains to 2 sides. Now this is simpler if it's a magnetic ballast because you've got starter in place. This is like the wiring for a starter fed LED tube. But in high frequency fittings, you don't have this starter connection. You're going to have to cut the connections and join them if you still want to use the lamp holders. Unless you replace the lamp holders as well, and then you might as well just buy a whole new fitting. Getting the conductors out of lamp holders is not that easy. Here's a picture to show you why. You have to destroy the lamp holder to get the conductor out sometimes. It's not that easy to pull out. But if you wanted to, you could rewire it. That's a job for an experienced and competent person. So just to recap, with magnetic control gear, you can just replace the tube as long as you replace the starter for an LED starter, or you can do a ballast bypass in one of two ways. The bypass with the LED starter will mean that you can generally use the tube in two directions, power to one end. Generally, you can only use the tube in one direction. With high frequency fittings, you can just replace the tube with a dedicated high frequency LED tube, or ballast bypass. The simplest way is just power to one end, and you'd use a live end LED tube. Just a quick word on lamp holders. The different types will have an effect on the safety and functionality of the fitting. You do get different types of lamp holder. One type you slot the tube in and twist it to connect to the live pins. The other type, which I always disliked, was the spring-loaded lamp holder that you pushed away to enable the tube to fit in the fitting. Then the lamp holder snapped back, making a connection. I never liked that because I was always worried about the tube falling out. The other version, the tube kind of gets locked in. With the spring-loaded version, you could be putting the tube in and connecting directly onto mains power. You should always switch off when changing LEDs or fluorescents. Another thing to bear in mind when you're retrofitting is the type of lamp holder installed. You get two different types, shunted and non-shunted. As you can see, the shunted are connected together. The non-shunted, you have two separate connections, and you get different types and different fittings. In double fittings, you often get shunted, passing on the power to the next lamp, and it can be quite difficult to tell, because obviously they're covered, and it can be quite difficult getting any probes onto the fittings to test to see if they're shunted or non-shunted. You can get an idea from how they're wired, but that can be troublesome as well. Conductor colours are often not much help, because it seems manufacturers of fluorescent lights seem to use any colour they want, so you have to trace out what's going to where, because you can see the problem. If you've got a solid link, you're going to get a short, or power might not be passed on. So let's have a look at some of the problems that can arise if we do not follow the manufacturer's instructions. So this is an LED tube with an old magnetic ballast. Works fine with the correct LED starter. I swapped the tube over, different direction, that works fine. Then I swapped out the LED starter for the traditional glow starter, and you can see it lights up a little bit, it glows dimly, then it just starts flickering as the starter opens and closes, just got a terrible flicker. Then I put the fluorescent tube back in with the LED starter, and you can see it won't start up, you just get a dim glow at both ends of the cathodes. There's not that spike from the starter to make the light work. Here we have the LED tube with the ballast bypassed, the starter removed and power to just one end. And that seems to work fine. I swapped the tube round and you can hear a little pop. You see a little flash. Not the most dramatic footage, I'll grant you that. But it took out the MCB and it ruined this LED fitting. So with the power to one end, the double-ended LED tube would work in one orientation, but flip it over, it failed. But of course these tubes failed because I wasn't following the manufacturer's recommendations. And we've got to consider the person who comes next to change the lamp. When you remove the ballast, somebody might come along at a further date, not realise, put a tube in, and they've got problems. Manufacturers often recommend you bypass the ballast, especially electronic ballasts, and you even get little stickers so the next person who comes along will know. If you ever bypass ballast, you've got to leave a note on the fitting and probably leave something by the distribution board as well, so they will know that the ballast has been bypassed. Here I've put a fluorescent tube back into a fitting that's had the ballast cut out, and you'll see at the far end you'll get a flash. That's the cathode burning out, tripped the MCB as well. Bypassing the ballast could cause other issues though. You have altered the light, so the manufacturer will not take any responsibility for that anymore. You've taken it upon yourself to modify something. In the guidance notes it mentions things like some fixtures have specialist functions, they might be explosion proof for use in dusty environments. These are things to think about. You start cutting bits out of those fittings, it might compromise the safety of the lamp. And you'll find that nobody recommends you doing this for emergency lighting fittings. Emergency lighting, just buy a whole new fitting. So we're getting these problems because we haven't followed the manufacturer's instructions. We're using the wrong fitting. We've connected it up incorrectly, or we didn't realise that something's been modified. So we've just got to make sure we do our homework, really. Get the manufacturer's instructions. Sometimes they don't make things that clear. Having a good understanding of how the lamps actually work is critical because you can foresee the potential problems. So I'm generally unsure about LED tube replacements. Some work absolutely fine with just a correct starter and tube replaced. Some you don't know, and there's potential for dangerous occurrences. Do try to buy quality fittings. Some of the unknown brands, we're not sure how they're wired, and we're not sure how well they're constructed. Have they got proper separation between the PCB and any aluminium extrusion that the tube's constructed of? Many tubes are made of glass now, plenty are made of plastic, and especially in the longer fittings that can be so floppy, you're concerned that they're going to fall out. So I guess my final word is, if you can, replace the entire fitting. If you can't, triple check everything. Anyway, that's this one. Thanks very much for watching. I hope it's been of some use. Also, don't try and short out your ballast to see what happens. I did that under controlled circumstances with the cat locked away. Be safe.